Hello everyone, welcome back to my channel. So in today's tutorial, learn something called as a graphics pipeline and learn how to render our first OpenGL triangle. Well, before getting into the tutorial, I have given you two questions from the previous tutorial. I hope you have solved them. So let's see the solution of those two questions. Now, the first question I gave you was to change the red component of the window color by pressing R plus up or down key. So I have used a variable here named R with a floating type and initialized it to some value like 0.0. Now I have replaced it with the static value I used in the previous tutorial here in the GL clear color function. Now, to change the value of R, I have used 2if here with 2glfw get key respectively, as you can see here. So, by running the program, the output looks something like this. Is it okay? Okay. Now, the second question I gave you was to change the RGB values of window color in some time related pattern. I hinted you to use the function glfw get key. So here I have taken another variable I of the floating type. Now the value of I used here is sine square glfw get time by 2. So you might have noticed that in the GL clear color the value of RGB always lies between 0 and 1. So the function that outputs the value between 0 and 1 and is periodic in nature is a sine function or a cos function. Okay. Now I have used different combinations of I here, like for R I have directly used I, for B I have used the cos square variable, and for G some random combination. It's your choice what are the combinations. So by running of the program, the output looks something like this. For my combination of I, the pattern may change for your program. That's not a big deal. Now, let's get back to our tutorial. So, in the previous tutorial, we created our first OpenGL window. So, you might have noticed that most of the functions we used there were from the library glfw. The thing is, we haven't delved into OpenGL till now. So to render anything using the core profile mode of OpenGL, we have to follow a certain process called the graphics pipeline. It isn't like that we have a function called gl.triangle, we pass on 3 vertices to it and boom, the triangle is drawn. No. This was the case in the immediate mode of OpenGL. However, in the modern OpenGL, we have to follow this graphics pipeline. So before getting into this graphics pipeline, I want to give you a tip that most of the concepts you will encounter today will be new for you, and it is highly possible that you don't understand them in the first go. So it is highly suggested that you rewatch this video until you understand what is this graphics pipeline, because it is important. Okay? So first of all, let's see some properties of the graphics pipeline. So basically, the process of transforming the 3D vertices into 2D pixels is done by the graphics pipeline. This graphics pipeline can be divided into two parts. The first part basically transforms your 3D vertices into 2D coordinates, and the second part transforms them into final colored pixels. Okay? This graphics pipeline consists of various steps which are highly specialized in nature. So, due to this nature, the various steps can be run parallelly. Due to this reason, various new graphics cards have thousands of processing cores for the graphics pipeline. So there are certain steps that OpenGL takes care for us. However, there are certain steps that we as programmers have to code for ourselves. These steps are called shaders. Okay? A shader is written in a C-like language called the OpenGL shading language, also called the GLSL. Is it okay? Now let's see the graphics pipeline. Okay, So the steps which are displayed in the gray color are taken care by OpenGL. However, the steps which are written in this blue color, we have to code them for ourselves. Okay. So the first thing we want to do is create something called as a vertex data. So basically, in this case, the vertex data contains all the three 3D vertices we want for the triangle. So note one point that the vertex data array can contain data other than the position of the vertices. We'll see what this data can be in the upcoming tutorials, not to worry about. So the thing is that this vertex data currently is contained in the CPU. However, the graphics pipeline run on the graphic processing unit or your GPU. So we transfer this vertex data and store it inside a buffer in the GPU. Okay. Now starts the graphics pipeline. So the first step of this graphics pipeline is called the Vertex Shader. Basically, the Vertex Shader takes input as a single vertex and it allows us to do some processing on these vertices. What type of processing we'll do, we'll see later. Okay. Now, all these vertices then goes in the shape assembly stage. Basically, all the vertices here combine to form a shape on the basis of the primitive we set it for. So, to draw a triangle, we'll set the primitive to real triangles. However, you can set that primitive to draw a simple points or to draw a line strip. Okay. Now, this assembled shape is then passed on to something called as a geometry shader and tessellation shaders. So, this geometry shaders and tessellation shaders takes the input as a whole shape assembled in the shape assembly stage, unlike the vertex shader where it takes single vertices. Okay. So the output of this geometry shaders and tessellation shaders is passed on to the rasterization stage. So in the rasterization stage, it maps the resulting primitives to the corresponding pixels on the final screen, resulting in various fragments for the fragment shader to use. Before moving on to the fragment shader, something called as clipping takes place. So to understand what is this clipping, we'll go back to the concept of viewport. So I hope you remember that viewport. So let's visualize it again. So I hope you remember this diagram from the previous tutorial. Let's summarize this. This was our window that was 800 by 600. This was our viewport that was 600 by 400. So what OpenGL does, it creates a virtual coordinate system inside the viewport where the coordinates are bounded by 1 and -1. For example, this left bottom corner will be -1, -1. Okay. So the coordinates that lie between this -1 and 1 are called the normalized device coordinates or the NDC. So any vertex that falls out of the range of this -1 and 1 is clipped out from the viewport. Okay, that is the process of clipping. Now let's get back to our pipeline. Now the next step is done by the fragment shader. Basically, the fragment shader colors this fragments that are produced in the rasterization stage. Now, the final step is the tests and blending, where various types of tests are conducted on the final image. We'll see what are these tests in the upcoming tutorials, not to worry about. Okay, so that's it for the graphics pipeline. If you like the video, press the like button and subscribe for more such tutorials. Thank you.